Hello and welcome back to your new Research Statistics course. Chapter 2 of this course has the subtitle Bird by Bird because all of my examples pertain to the beautiful birds that live in the ponds and wetlands near my home. In this lesson, Chapter 2b, we'll learn how to fill in the analysis column of the RARA table. There are different kinds of analyses used for each type of question, descriptive versus correlational, and for each type of variable, categorized versus quantified. It may seem a little overwhelming to memorize all these different tests, but it really is quite manageable when you use the tables I'm showing you. The topics for this lesson are: first, we'll review types of questions, types of variables, and then I'll introduce the right angle a la carte table, or the RALA table, and then we'll look at a couple of examples. Now, we have a question: should I use different kinds of statistics for different kinds of questions and variables? And the answer is yes. You need to develop a strategy to pick the correct statistical test for each part of your study. And that's what I'm going to teach you today, how to pick the correct statistical test. All you need to do is identify the type of question you have, descriptive versus correlational, and figure out whether the variables are categorized or quantified. Keep in mind, this is a simple matching task, and there are tables available that guide you in choosing the correct statistic. Today I'm going to show you how to use these tables. For descriptive questions, what is the difference between categorized and quantified characteristics? Let's review the concepts and the terms we learned in Lesson 2. When measuring categorized characteristics, we need to perform a sorting task. That is, we put signets into separate groups that are qualitatively different than each other. For example, we've seen this slide before. We can look at one swan family and we can see two categories of signets. We see a risk taker, the one that's swimming away from mom, and the safety seekers who cluster around the mom. These groups are qualitatively different from each other in terms of behavior. We can ask, how many are in each group? How many are risk takers? How many are safety seekers? When measuring quantified characteristics, we need to think about how much or how little of some characteristic each signet possesses. In other words, how can we classify the signets in terms of quantitative differences? For example, I can ask, how much does each baby swan weigh? The characteristic body weight is called a quantified variable. Or, how many days does each signet survive on the pond? Days of survival is another quantified variable. And we can then measure the way the signets differ in the quantity of these characteristics. For correlational questions, do statistics differ for each combination of variable type? So for correlational questions, we can have either a categorized or a quantified predictor, and we can have either a categorized or a quantified outcome, and we can mix and match the types of variables. So in the slide ahead, we're going to go through the options for correlations between each type of variable pair. How does a researcher pick the correct statistic to answer a correlational question? You're going to use the right angle a la carte or RALA table. And you're going to find out what the RALA table is in just a minute. This is the right angle a la carte table for descriptive questions and categorized variables. Here are some examples of descriptive questions you might ask about categorized variables. You might ask, how many? What is a typical value? How much do values differ from each other? In column 2, you list the type of variable. In this example, all the variables are measured as categorized variables. In column 3, you'll fill in the type of analysis for each question. I won't fill in the particular statistics for these questions yet. Once we learn these statistics in Chapter 3, you can come back and fill in Column 3. The reason it is called the a la carte table is because you'll pick and choose the type of analysis that fits your research needs at any particular time. Just as you would pick and choose a particular treat off an a la carte dessert tray that fits your taste bud needs at any particular time. Notice that the rah-rah table from the prior lesson and the rah-lah table in this lesson look very similar when we're talking about descriptive questions. This is the sister table to the one we saw before. This is the right angle a la carte or rah-lah table for descriptive questions with quantified variables. The methods in the analysis column can be filled in after we learn these methods in Chapter 3. A feature presentation called the right angle a la carte or rah-lah table for correlational questions. We put our two themes together, the temporal location of the characteristic, predictor versus outcome, and the level of the characteristic, categorized versus quantified, and we can consult this cross table that shows how to pick the correct statistic for each combination of level and time. We can have two kinds of predictor variables and two kinds of outcome variables, so we know we'll need a 2x2 cross table to display all the possible combinations of time and level. Students are often confused by the funny-sounding names of the various statistical tests that go along with each combination of question type and variable type. Traditionally, the statistics have been named for the last name of the person who invented them. To make it easier to remember which test goes where, I named them according to the first name of the person who invented the statistic. The first names are more familiar and easier to remember. Chi-square was invented by Carl Pearson. ANOVA, which is the shorthand name for analysis of variance, was invented by Ronald Fisher. Logistic regression was invented by David Cox, and simple regression was invented by Francis Galton. These names aren't the official names for these tests. I just use them to help students feel more comfortable as I introduce you to the tests. This course is composed of 5 mini-courses. The first mini-course, the one we're in now, gives an overview and goes into detail about descriptive statistics. In future lessons, we'll cover each of the tests named in the quadrants of this table. We're only using the first names for now. In future lessons, we'll be using the technical names. These 4 tests, or some version of them, are the heavy lifters for correlational questions. The course is divided into 5 mini-courses. In the table, the mini-course linked to each statistic is given with the superscript MC. Mini-course 5 covers concepts about chi-square. I also call this Carl's test. Mini-course 4 covers concepts about analysis of variance, or ANOVA. I called this Ronald's test. And mini-course 2 and 3 cover concepts about simple regression. I called this Francis's test. Note, logistic regression, or David's test, isn't linked to a mini-course. This is an advanced topic and isn't used very often in research. It'll be covered in an advanced course. As you go through the course, you may choose to pick and choose from the mini-courses, just as you would pick and choose from an a la carte menu at a restaurant. Most research requires introductory and descriptive statistics, which are covered in mini-course 1 and 3. So everyone should take those mini-courses. However, for your correlational questions, you may find you only need chi-square. If you are pressed for time, you can focus your time on mini-course 5, which is chi-square or Carl's test, and so on for the other kinds of correlational questions. These are the basic things you need to know about picking the correct statistics for a given research design. There are some additional variations on this theme to match any kind of study you design. These variations will be covered in an advanced course. We saw this rah-rah table in Lesson 2A. So research question 1 goes as follows. Is there a correlation between signet weight and days of survival? So time 1 is the predictor and it's quantified. Time 2 is the outcome and it's also quantified. And so we see on the RALA table that this combination of variables calls for mini courses 2 and 3, which cover Francis's test, also called simple regression. Question 2 goes as follows. Is there a correlation between risk-taking status and days of survival? This has a categorized predictor and a quantified outcome. We see this combination of variables calls for mini course 4, Ronald's test, also known as ANOVA, which is shorthand for analysis of variance. So this is the end of Chapter 2b. Next up, we'll be looking at Chapter 3 and visual frequency distributions, looking at data.